Hello, space enthusiasts and curious minds alike. Today, we're diving into an exciting journey through the clouds of Venus, the second planet from the Sun. Often dubbed as Earth's twin due to its similar size and structure, Venus offers a fascinating glimpse into a world of extremes. Stay tuned as we explore the top facts you need to know about this mysterious neighbor. Venus, dazzling as the brightest beacon in our night sky, holds the title of the most luminous and hottest planet in our solar system. This fiery celestial body, composed of rocky terrain, derives its name from Venus, the Roman goddess of love and beauty. Notably, it stands alone as the only planet in our solar system named after a female figure, adhering to the naming conventions set by the International Astronomical Union, which are universally recognized by the astronomical community. The reason behind its enchanting name? Venus outshines all in its celestial class, much like the deity it's named after, who was revered across the Roman and Greek pantheons as the epitome of beauty. Interestingly, to the ancient Greeks, this radiant planet was known as Aphrodite. In the tapestry of ancient celestial lore, Venus mystified observers as it shimmered in the twilight skies, believed to be two distinct entities, the evening star and the morning star, appearing at sunset and sunrise respectively. In the lexicon of Christian Latin, these celestial phenomena were known as Vesper and Lucifer. Intriguingly, the name Lucifer, which means light-bringer, later became synonymous with Satan prior to his fall from grace. Fast forward to the space age, and Venus reveals its true nature, an infernally harsh landscape that challenges even the most robust spacecraft. The hostile conditions on Venus have made it notoriously difficult for these explorers to endure, quickly succumbing to the planet's scorching surface. This stark contrast paints a dramatic portrait of a planet that once evoked beauty and light, now embodying a fiery world cloaked in mystery and peril. Just how scorching is Venus? Picture a world where the thermometer soars to an unimaginable 880 degrees Fahrenheit, 471 degrees Celsius, a searing heat capable of melting lead. And what lies beneath this fiery exterior? Venus boasts a structure strikingly similar to Earth, with a core of iron wrapped in a rocky mantle. Yet, it's the planet's atmosphere that truly sets it apart, dominated by a thick, toxic blanket of carbon dioxide, which makes up a whopping 96%, and nitrogen at 3.5%. This Venusian air is no place for the faint-hearted. Traces of carbon monoxide, sulfur dioxide, water vapor, argon, and helium complete the mix, making up the remaining 0.5%. This cauldron-like atmosphere creates a vision of Venus as a harsh, hostile world enveloped in an almost otherworldly air. Venus dazzles as a celestial beacon, highly visible from Earth thanks to its reflective cloud cover. In the night sky, it gleams like a brilliant white gem, ranking as one of the brightest natural objects we can see. According to NASA, Venus reaches a maximum magnitude of nearly 5, making it exceptionally luminous compared to the Moon's 14. The lower an object's magnitude, the more it captivates the eye with its brilliance. Upon closer examination, NASA describes Venus's hue as rusty, a stark contrast to the deep red rust found on Mars. Instead, images returned by various missions reveal a palette of subtle reds, browns, and yellows, hues that Cornell University attributes to the plethora of volcanic rocks scattered across its active surface. However, the true color of Venus remains shrouded in mystery, hidden behind dense sulfuric acid clouds that cloak the planet. Only satellites equipped with specialized sensors can glimpse its surface through this veiled atmosphere. For any human daring enough to venture there, surviving the scorching temperatures and crushing pressures would be a monumental challenge, leaving robotic explorers to unveil the secrets of Venus on our behalf. Venus's orbit lies along the ecliptic, the same celestial highway that guides the planets, the Sun, and the Moon through our solar system. This alignment is not by chance. it reflects the fundamental plane of our solar system's formation. Venus's proximity to Earth's orbital path often results in conjunctions, dramatic celestial events where Venus aligns closely with the Moon and occasionally other planets, creating stunning alignments that grace our skies several times a year. Often referred to as Earth's twin, Venus shares striking similarities with our home planet in terms of size, mass, density, composition, and gravity. Despite being slightly smaller, Venus holds about 80% of Earth's mass, showcasing just how close these two planets are in cosmic terms. Venus is a rocky world, not a gas giant. Beneath its hostile skies, the planet boasts a metallic iron core approximately 2,400 miles, 6,000 km wide, surrounded by a molten rocky mantle about 1,200 miles, 3,000 km thick. The surface, primarily composed of basalt, features a crust that averages 6 to 12 miles, 10 to 20 km in thickness. The title of the hottest planet in the solar system doesn't come to Venus by its proximity to the Sun, but through a more sinister mechanism. Its thick atmosphere acts like a thermal blanket in a runaway greenhouse effect far more extreme than Earth's current global warming scenario. This results in surface temperatures soaring to 880 degrees Fahrenheit, 471 degrees Celsius, hot enough to melt lead. Spacecraft that have braved Venus's surface have survived only a few hours before succumbing to these brutal conditions. But the challenges don't stop with the heat. Venus's atmosphere, composed predominantly of carbon dioxide with clouds of sulfuric acid and mere traces of water, creates a crushing pressure over 90 times that of Earth's, akin to being 3,300 feet, 1,000 meters underwater. This combination of scorching temperatures and oppressive atmospheric pressure crafts a world that, while Earth-like in some aspects, is nightmarish in others. Venus presents a stark and arid landscape, a world where water once possibly trickled but now stands utterly desolate. During its fiery infancy, relentless ultraviolet rays from the sun swiftly evaporated any primordial waters, leaving Venus perpetually scorched. Today, any semblance of liquid water would vaporize instantly under the searing embrace of its ozone-rich atmosphere. The surface of Venus is predominantly a vast expanse of flat, smooth plains, punctuated by an impressive array of volcanoes, some still smoldering with activity. These geological giants vary in size from modest, half-mile wide mounds to colossal structures spanning up to 150 miles across. Their historic lava flows have sculpted intricate networks of canals, extending over 3,000 miles in serpentine paths across the planetary surface. Complementing these volcanic plains are 6 rugged mountainous regions that occupy roughly a third of Venus's surface area. Among these, the majestic Maxwell Montes stands out, stretching some 540 miles long and soaring nearly 7 miles high, claiming the title of the planet's highest peak. Venus is also adorned with unique geological features unseen on Earth. Among these are the coronae circular structures that could stretch up to 13 miles across, believed to form from uprising hot material that distorts the surface. Additionally, tesserae tile-like raised terrains crisscrossed by multiple ridges and valleys add to the planet's complex topography. Interestingly, Venus is one of the lonely planets in our solar system without a moon, sharing this rare characteristic only with Mercury. The absence of natural satellites around these planets remains a mystery, hinting at a unique and intricate celestial history that influences whether moons come to orbit or not. Each planet, after all, writes its own cosmic saga across the eons. Venus spins on its axis with an unhurried grace, taking a staggering 243 Earth days to complete a single rotation, the slowest of any major planet. Intriguingly, a day on Venus surpasses its year in length, a peculiarity that could be attributed to its dense atmosphere acting as a colossal brake, slowing its spin. This leisurely rotation prevents Venus's metallic core from generating a magnetic field akin to Earth's. In fact, Venus's magnetic field is a mere 0.15 times that of Earth's. When observed from above, Venus exhibits a unique trait. It rotates in the opposite direction to most other planets. This retrograde rotation means that if you stood on Venus, you would witness the sun rising in the west and setting in the east, opposite to what we experience on Earth. Venus orbits the sun in about 225 Earth days, which under normal circumstances would mean its days outlast its years. However, due to its retrograde rotation, the time from one Venusian sunrise to the next is about 117 Earth days. The last time Venus crossed directly between Earth and the Sun, a celestial event known as a transit, was in 2012, and we won't see this happen again until 2117. Venus boasts an atmosphere so thick and hostile, it's nothing like what we have here on Earth. Composed mainly of carbon dioxide with clouds of sulfuric acid, the Venusian atmosphere creates a greenhouse effect that makes it the hottest planet in our solar system, even hotter than Mercury. Surface temperatures can soar up to 470 degrees Celsius. This extreme heat poses a significant challenge for space exploration. Despite its inhospitable atmosphere, Venus's surface is a geological wonder. It features numerous volcanoes, mountain ranges, and vast plains made from basalt rock. Interestingly, Venus does not have plate tectonics like Earth, but it does have volcanic activity that could hint at a different kind of tectonic activity beneath its surface. The Venusian surface remains a puzzle for scientists, obscured by its dense atmosphere. Over the years, various missions have attempted to penetrate the secrets of Venus. The Soviet Union's Venera series and NASA's Magellan orbiter have provided most of what we know today. These missions revealed the extreme surface conditions and detailed maps of the planet. Currently, new missions are being planned, including NASA's VERIT, CAS and ESA's Envision, aimed to further explore Venus's atmosphere and geological phenomena. Studying Venus helps scientists understand more about Earth's climate and geological history. By comparing Venus's greenhouse effect to Earth's, researchers can better predict how Earth's climate might change in the future. Additionally, understanding why Venus became so inhospitable could provide crucial insights into preserving habitability on Earth and other planets. Unlike Earth, Venus does not have a significant magnetic field, which contributes to its extreme atmospheric conditions. Without a magnetic field to deflect solar wind, the Sun has stripped away significant amounts of Venus's original atmosphere, leading to the thick, toxic environment we observe today. This loss of atmosphere also explains why Venus has no moons. Any potential satellite might have been blown away by solar winds or never captured. Venus exhibits phases similar to those of the Moon when observed from Earth. These phases were first documented by Galileo and were instrumental in shifting scientific views away from a geocentric model of the solar system to a heliocentric one. Observing these phases can provide critical insights into the planet's atmosphere and its interactions with solar radiation. The clouds of Venus are not only thick and extensive, but also composed of sulfuric acid. These clouds reflect about 75% of the sunlight that falls on them, making Venus the brightest planet in our sky and contributing to its nickname as the morning star or evening star. The high reflectivity also helps scientists use radar mapping to study the planet's surface. Venus has some of the fastest moving winds in the solar system. Despite its slow rotation, wind speeds can reach up to 360 kilometers per hour, 224 miles per hour in the upper atmosphere. These super-rotating winds circle the planet much faster than Venus itself rotates, creating a dynamic and turbulent atmosphere that is a subject of ongoing research. Scientists believe that Venus undergoes a catastrophic resurfacing event every few 100 million years. This theory is based on the observation that Venus's surface appears relatively young, geologically speaking, with few impact craters. Such events would imply a volatile geological life for the planet, dramatically altering its surface and releasing vast amounts of volcanic gases into the atmosphere. Interest in Venus has reignited with proposals for new missions. NASA's proposed mission, DAVINC aims to send a probe into the Venusian atmosphere to study its composition and dynamics directly. Similarly, the ISRO Indian Space Research Organization plans to launch its first mission to Venus, Shukrayan-1, to study the surface and atmospheric chemistry more comprehensively. Venus exhibits a phenomenon known as night glow emission of light by a planetary atmosphere when the sun is on the other side of the planet. Venus's night glow is particularly fascinating because it helps researchers understand the composition of its atmosphere and the processes occurring without sunlight, including how oxygen atoms recombine into molecules in the dark. Despite its harsh surface conditions, some scientists speculate about the potential for microbial life in the temperate upper layers of Venus's atmosphere. Here, temperatures and pressures resemble those on Earth's surface. The discovery of phosphine, a gas typically produced by biological processes on Earth, has fueled this speculation, although its detection remains controversial. The surface of Venus features unique geological formations such as tesserae complex, ridge-like structures that are older than the surrounding basalt plains. These features suggest that Venus once had tectonic activities similar to Earth's but evolved differently due to its harsh climate and atmospheric conditions. One of the most peculiar aspects of Venus is its rotation. It rotates on its axis in the opposite direction to most planets in the solar system, a phenomenon known as retrograde rotation. This means that on Venus, the sun would appear to rise in the west and set in the east. Additionally, Venus has a very small axial tilt of about 3 degrees, which results in minimal seasonal variation compared to Earth. The surface pressure on Venus is crushingly intense, about 92 times that of Earth's. This is equivalent to the pressure you would experience nearly a kilometer below the ocean's surface on Earth. Such extreme pressure poses significant challenges for lander missions, as any probe must be robust enough to withstand these conditions without being crushed. Venus is dotted with thousands of volcanoes, more than any other planet in our solar system, including many that are believed to be still active. This extensive volcanism is thought to contribute significantly to the sulfur content in the atmosphere and may play a key role in the ongoing surface transformation of Venus through various resurfacing events. Due to its opaque atmosphere, traditional optical telescopes cannot view Venus's surface. Instead, scientists use radar mapping to penetrate the cloud cover and map the surface. Missions like NASA's Magellan used synthetic aperture radar to provide detailed maps that revealed the planet's complex geology, showing features like volcanic domes, rift valleys, and sprawling highland plateaus. The Pioneer Venus mission by NASA in 1978 was pivotal in our understanding of Venus. It consisted of an orbiter and multiple probes that descended through the atmosphere. These probes conducted the first direct measurements of Venus's atmospheric composition, winds, cloud properties, and surface conditions, which are invaluable to our current understanding of the planet. Venus is not only the second brightest object in the night sky after the Moon due to its highly reflective clouds, but also one of the first stars to appear during twilight. This visibility and brightness have made Venus a significant feature in various cultures' mythology and observations, often associated with beauty and warning. Venus features a complex sulfur cycle that is critical to its cloud formation and atmospheric chemistry. The high volcanic activity releases vast amounts of sulfur into the atmosphere, which then combines with other elements to form sulfuric acid and other compounds. These processes are important for understanding not only the planet's weather patterns, but also its potential for hosting life. While Mars is often considered the prime candidate for terraforming, some scientists also speculate about the feasibility of terraforming Venus. Ideas include altering its atmosphere to reduce the greenhouse effect, or even introducing genetically engineered microorganisms that could live in its upper atmosphere and convert the dense CO2 into breathable oxygen. The extreme conditions found on Venus have influenced space policy and mission planning, emphasizing the need for advanced materials and technologies. This necessity drives innovation in spacecraft design, materials science, and robotic systems, pushing the boundaries of what is possible in space exploration. Given Venus's proximity to the Sun, the planet receives a substantial amount of solar energy, which could be harnessed for future missions. Solar power could be particularly effective in the upper atmosphere, where sunlight penetrates the cloud layers. The potential for using solar-powered airships to explore Venus is an area of ongoing research, offering a way to study the planet's atmosphere for extended periods. Venus's atmosphere exhibits fascinating dynamics, including a phenomenon known as the superrotation. The entire atmosphere circles the planet in just 4 Earth days, much faster than the planet's own rotation. Understanding this rapid atmospheric movement could provide insights into similar atmospheric phenomena on Earth and other planets, potentially aiding in weather prediction and climate models. Landing a spacecraft on Venus presents numerous challenges, primarily due to the extreme temperatures and pressures. Past landers, like those from the Soviet Venera program, only survived a few hours before succumbing to the harsh conditions. Future missions must rely on advanced materials and engineering to improve lander designs that could withstand Venus's severe environment longer. Venus showcases a wide variety of geological features, including flat plains covered with volcanic flows, mountainous regions, and vast highland areas known as terrari. This diversity suggests a complex geological history involving volcanic activity, tectonic shifts, and possibly water activity in the distant past. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.